Welcome, and thank you for watching this video. I think it'll help you um, prepare for esters. We will continue this in class. There are a few examples at the end of this lesson that we'll do in class. I might give you some clues right now, but we'll do in class. And by listening to this, we'll have more time to ask questions, go over examples. So glad you're doing it. Okay, but before we start esters, let's do a bit of review. Just a couple of questions. Okay, so the last functional group we did was carboxylic acids. Previous to that was ethers, and we can recognize that the first question here has an ether, right? We have an alkyl component here, and to the right as well, separated by an oxygen. So it's going to be an ether, and it's asking us to name this structure. So let's do that. It's also asking us specifically to name it using the functional group method, or what we call in class the branch method. So here's a branch to the right, here's another branch to the left, and we know that this is methyl. And careful with the one to the left, the common mistake is to think that it's phenyl. When it isn't, we have an extra carbon right there, and so we would call that benzyl. Right, so naming it now alphabetically, we get benzyl, followed by methyl, since it's the branch or the functional group method of naming this ether. And when we use a functional group method or the branch method, we just add the word ether to the end. And that's that. Now, the next review question, it's not a nomenclature question. It's asking you now to write the chemical formula and the conditions necessary for the halogenation of 1-butene. So first, let's draw 1-butene. And there it is. If you're going to halogenate it, you're going to pick a halogen. Of course, it's going to be diatomic, and it can be chlorine, bromine. We decided to go with bromine here. And now you're going to write your reaction arrow. Give you a second to think about that and what conditions are going to be above and below the reaction arrow. Thinking right now of the catalyst necessary for the halogenation of an alkene. Okay, well, we will review this in class, but moving on, we need carbon tetrachloride, and that's going to yield a fully saturated alkyl halide, and in this case looks like that. Good. Again, we'll review this in class, but just so that you get started, we'll wrap that up and we'll continue now with the topic at hand and esters. So here is the general formula for an ester. There are two components here. This does look a little bit complicated compared to other ones we've done, but if we break it apart, it should be better. To the left, we have your acid component, what was derived from a carboxylic acid. We'll more on that later. And to the right, it's what was derived from an alcohol. So a carboxylic acid and an alcohol came together under the right conditions. We get esterification. We'll talk more about the synthesis of esters, but for naming it, it actually helps. For naming esters, it actually helps if we are able to identify which one used to be the carboxylic acid component of the ester and which one used to be the alcohol. So let's start looking at that now. So the general formula looks like this. The portion of the ester with the carbonyl group came from your carboxylic acid. The alcohol component is the has the oxygen here, and that came from your alcohol. And it's important to recognize where these come from, where these were synthesized from, because the alcohol component, its root name, will be used as the first portion of the new ester name, and the carboxylic acid will be the second portion of the ester name, where the first carbon is the one attached to the carbonyl. Moving on. Now, we're not going to get, as we don't usually read over the nomenclature rules. We get straight into the examples, and by doing that, go over each of the rules. But I do want to what I usually do is point out what does change in the name, the main thing that changes in the name. So since there are two portions of an ester, we have to consider both. So the alcohol component is going to become your first name, and we're going to remove the all, right, and add an YL to it. So that's the first rule here. Second rule, we're going to consider its name, its carboxylic acid name. We're going to take out the oic acid and add O8. Everything else, as usual, will be named as we usually have, numbered and named as we've been practicing a lot. So, first example, and I seem to have forgotten to move the banana here, pretend you didn't see that. And the reason there is a banana there is that esters are known to have, they have scents. And this one particular ester here, which we'll go over in just a bit, that has a scent, a banana scent. So first recognizing this is an ester. Yes, this is an ester lesson, but on a quiz test exam, it's not going to be that obvious. So what we do is you look for a carbonyl, C double bond O, where that C is attached also to an oxygen. So that's an ester. Off to the right here, we see that this is an alcohol component. It used to be methanol. We take out the ol and add a YL. It becomes methyl, pointed out right there. To the left, we have 1, 2, 3 carbons. It used to be 3-carbon propanoic acid. Take out the oic acid and you add the new ending, and it's O8. Put it together with the alcohol component first, we get methyl propanoate. Next example. Slightly more challenging here on the alcohol components, not to the right, doesn't always have to be, but recognizing that it's attached to an oxygen and has 1, 2, 3, 4 carbons. What makes it slightly more complicated is that it now has a methyl group here. So carbon 1 off the oxygen, carbon 1, 2, 3 off the third carbon, we have a methyl group off a parent, off a 4-carbon parent, which used to be butanol. So it used to be 3-methyl butanol. We take out the all and add a YL, so it'll look like this. There we go. And the 2-carbon carboxylic acid used to be ethanoic acid. As per our rules, we take out the oic acid and we add O8 to ethanoate. Putting it all together, we get 3-methyl-butyl ethanoate. Continue with a few more examples. There's an apple here for a reason. This gives you an apple scent, this particular ester. We've identified that we have 1, 2, 3, 4 carbons off of what used to be the carboxylic acid component. With 4 carbons used to be butanoic acid. Changing the ending of butanoic acid, we get, I'm going to work backwards here, we get butan O8. Now uncovering that alcohol component, it's just a single alcohol, rather a single carbon, which would mean methanol. Take out the all, add YL, put it together, and we get methyl butanoate. Okay, next, going over different examples here, something you will certainly see. The carboxylic acid component, it would have been a cyclic carboxylic acid. And we know that this is naming this as if it were just a carboxylic acid, or just naming that carboxylic acid component would have been named by keeping the end as carboxylic acid. Right, you can refer back to your notes on your carboxylic acid part. The rules don't change though, so hopefully your nomenclature intuition is going to kick in. And all you do is you take out the carboxylic acid, here listed written in quotations, and add as you would O8. The alcohol component here used to be a 2-carbon alcohol, right? That would be ethanol. So that would be written first. We'll see what that looks like. Ethyl, right? We take out the all, add a YL. And this is going to then be benz, take out the carboxylic acid component, and we get benzoate, right? Now this is perhaps a bit new. Let me help you out with this a little bit. Let's right. So if it were just a carboxylic acid, we would get I'm going to backtrack a little bit. Benzene, then as a carboxylic acid would be benzenoic acid. Right here, what we're doing is we're taking out the oic acid and oic acid, and we're adding just the ending we would normally for an ester, and it would be benzoate. Right? We'll review more of this in class. Oh, we'll leave that uncovered. Okay, moving on. Switching to full screen, we see that we have your alcohol component in this box here. It is 1, 2, 3 carbons long, and your carboxylic acid is 1, 2, 3, 4 carbons long. Let's do the alcohol first. 3 carbons long, propanol would change to propyl right there. And the alcohol component is 1, 2, 3, 4 carbons long. it's no longer butanoic acid, it is butanoate. So propyl butanoate. Okay. After we do nomenclature, a few examples of nomenclature, we usually then go into properties and characteristics of esters. So we're going to compare these properties to other functional groups we've covered. So an ester is less polar than its acid, and the reason for that, if you think about the structures, it's lost its hydroxyl group that allowed it to create those stronger hydrogen bonds. So without that, it's lost a bit of its polarity, therefore a bit of its intermolecular forces, and we'll get to the consequences of that in the next few points. So we can at this moment just say that it is less polar. Also, you have two alkyl ends um, naturally, of course, in esters, so that those two alkyl ends will make it less polar and more non-polar. So it has, because of this loss of hydrogen bonding and lower intermolecular forces, it's going to therefore have lower melting and boiling points for those reasons there. Um, and as we've seen in the past, lower molecular weight or lower mass esters, that means smaller esters, can be gases at room temperature. And the longer they are, their phases will change. A higher molecular weight, longer chain carboxylic acid or alcohol derivatives are going to give you larger esters and are going to have greater intermolecular forces, which will form liquids at room temperature, liquid esters, or even waxy solid esters. Right, so we've covered why that is when we talked about hydrocarbons and other functional groups. And this we've mentioned already, they're usually characterized by strong scents. Now, these scents we're going to do a lab on we're going to do an ester lab, and we're going to synthesize our own scents, our own esters, and we'll see that those that have lower molecular weights are a little harder to detect because they're more volatile, and if we don't do it properly and carefully, they will escape into the air, into the atmosphere, and we won't be able to identify it by its scent as easily. Right, more on that when we do our lab. Okay, now how esters are formed, and we already have hopefully a pretty good understanding now that it comes from an alcohol component and from an acidic carboxylic acid component. And this reaction, this synthesis reaction, is called esterification. And it's also called a type of condensation reaction because as a result of this esterification, we get water as a byproduct. Now, what happens here is your OH group from your acid is going to combine with the hydrogen from your alcohol, creating H2O, creating your water, creating an ester bond between what used to be your alcohol and the acid. Right. So conditions to highlight here, since we've already talked about how this already reviewed how this is formed, is going to be heat and a strong acid, usually sulfuric acid, concentrated sulfuric acid. Okay, so examples. Here, you're asked to write a reaction for the esterification of, and that's your ester, given to you here, ethyl butanoate, and that's the scent responsible for a pineapple scent. Rather, that's the ester responsible for a pineapple scent. So ethyl butanoate, you need to write the two reactants, namely the carboxylic acid and the alcohol. So draw those along with the conditions required to make that product. So if you'd like, you can pause right now, give it a try. Um, you can do that now, but we'll just continue in the video. So I'm going to bring the answer out here. But actually, before I do that, let's talk about this. To the right, we have two carbons of what would be your alcohol, right? So that is going to be ethanol. It would have been ethanol. That is your alcohol. One, two, three, four off of so four carbon acid would be butanoic acid. So here is your butanoic acid component, one, two, three, four. Continue pulling this out to the side. We have two carbons, as we have here, two carbons alcohol in the presence of an acid, and I am missing heat here, so be sure to make that correction. And here we have ethyl butanoate as our final product, matching up the stars there, and that's your reaction. Now this is written in a condensed formula, but you can write it, feel free to write it however you wish, to draw it however you wish. Okay, next example. And we'll detail these examples in class. We'll go over them again. What you could do now, though, is try to answer it yourself. You can see I have a timer here. In class, I would have paused and giving you a couple minutes, 2 or 3 minutes in your groups to come up with the answer yourselves. So if you're watching this video right now, feel free to pause the video and give it a try. Right, we're going to continue though. And we have the question asking us to write the reaction for the esterification of ethyl methanoate. That gives you a rum scent. If you go to the grocery store and you buy concentrated rum scent, it's not actually rum, right? It's likely going to consist of an ester. And ethyl methanoate would give you that rum scent. So the esterification reaction would mean that the ethyl would have come from ethanol and that the methanoate would have come from methanoic acid. Looks like this. So 2 carbon alcohol, 1 carbon carboxylic acid. I am missing, importantly, important to say, to note that I am missing your catalysts here. You should have heat and you should have an acid. Don't forget though, as it's listed here, do write the byproduct of water. Right, make that correction here. Heat and acid as conditions. Now you'll see these two half arrows here a lot in our equilibrium unit. For now, just know that it's at the moment it's equivalent to a reaction arrow. Right. So esters undergo reactions themselves. Now here again is your general form of an ester, together with a strong base, separate into its ions, sodium and hydroxide, and quite a bit of heat for quite a while. We will hopefully have time to do this reaction. It's called a saponification reaction. And will produce in this reaction from an ester is you'll break this ester bond and you'll create a sodium salt. And as a byproduct, an alcohol, which usually is then, because of all of that heat, it's lost to the atmosphere through evaporation. And this is the process behind making soap, synthesizing soap, hence the name. You don't need to copy this down, but here we see a triglyceride or a component of a fat or oil. We're going to use shortening likely ourselves. Hopefully we'll have time in class to do this together with a strong base. Byproducts will be glycerol and 3 soap molecules. This glycerol will separate out, and we'll see how we'll take that portion out, and then we'll neutralize the leftover sodium hydroxide so it'll be safe to handle, and we'll make soap in class. More on that when we do that. So these next few examples, I'd like to do with you in class. So give it a try. It's great to give it a try yourself. If you make a mistake, don't erase it. Don't scratch it out so you can't read it because you're likely to make the same mistake again. We will do these examples in class. Just to go over the question though, because it is a good idea for you to do it now. Um, Here you're asked to not write names necessarily. The focus here is to write the reaction for the production of. This is recognizing that this is hopefully you're thinking about the answer in your head, this is a carboxylic acid. State its reactants and conditions. Now, this is review, right? This isn't specifically on esters, although it will help us to create an ester. It's asking you to begin with an alkene as a starting reactant. Great review example, and as we are going to start organic synthesis very soon, this would be a great example to begin with. So take a few minutes, try doing this yourself. We'll move on to the next one. This is going to be in class practice. So here the question is the task is to name the following, and you're going to state the alcohol and the acid from which it was made. All right, so we'll name this and we'll write what the name is of the 2 reactants that are required to make it. We'll do this together in class. This as well. Here you're asked to draw the chemical structures of the reactants and products and include all necessary conditions. Those are your catalysts that we went over. Answers here, yes, but let's wait to do that in class as well. And that is your home fun or your class fun. Tomorrow we should be able to, or whenever we do get to it, we will be able to answer questions in class, do this question. Your worksheet, your practice is going to be carboxylic acids and esters worksheets. So some extra practice on naming carboxylic acids and their synthesis, as well as esters covering this topic. See you in class.